So part 284C3M1B7C8E13C9C6D3P38D12. Line 22f1fa19c3m1b7c8e 13c9c6d3p38d12. Oxidation, copper films, nanowires, 5G Wow Seti. Here's our alien radio signal. So this one's about copper nanowires, graphite films, and keyword research for the UFO spaceship in WOW data. February 23rd, 2013. Today's the 27th. The keyword nickel-copper alloy electrodes, and then went to Cupronickel nanowires from the previous video, line 22f1fa 19c3m1b7c8e 13c9c6d3p38d12. Cupronickel nanowires conductors UFO 5G Wow Seti. Quotes from blogs: the researchers at Duke University have created a new set of flexible, electrically conductive nanowires by combining copper and nickel. The cupronickel nanowires, in the form of a film, conducts electricity even under conditions that break down the transfer of electrons in plain silver and copper nanowire, claim the researchers. There's a picture of it. Because films made with copper-nickel nanowires are stable and are relatively inexpensive to create, they are an attractive option to use in printed electronic products, like electronic paper, smart packaging, and interactive clothing, said Benjamin Wiley, an assistant professor of chemistry at Duke. His team describes the new nanowires in a nanoletters paper. Here's Benjamin Wiley. He's the assistant professor of chemistry at Duke, and said since films made with copper-nickel nanowires are stable and are relatively inexpensive to create, they hold potential in printed electronics. Applications in products like electronic paper, smart packaging, and interactive clothing. The new copper-nickel nanowires are the latest nanomaterial Wiley's lab has developed as a possible low-cost alternative to indium tin oxide, or ITO. This material is coated on glass to form the transparent conductive layer in display screens of cell phones, e-readers, and iPads. Last year, Wiley's lab created copper nanowire films that can be deposited from a liquid in a fast, inexpensive coating process. The conductive films are much more flexible than current ITO film. Copper is also 1,000 times more abundant and 100 times cheaper than indium. One problem with copper nanowire films, however, is that they have an orange tint, not be desirable in a display screen, and copper-based films oxidize when exposed to air, turning old penny green. Nickels, however, rarely greens. Inspired by the US 5-cent nickel piece, Wiley wondered if he could prevent oxidation of the copper nanowires by adding nickel. He and his graduate student, Aaron Rathmell, who's this guy here, developed a method of mixing nickel into the copper nanowires by heating them in a nickel salt solution. Within a few minutes, the nanowires became much more gray in color, Wiley said. Rathmell and Wiley then baked the new nanowires at various temperatures to test how long they conducted electricity and resisted oxidation. Tests showed the copper-nickel nanowire films would have to sit in air at room temperature for 400 years before losing 50% of their electrical conductivity. Silver nanowires lost half their conductivity in 36 months under the same conditions, and plain copper nanowires only lasted 3 months. While the copper-nickel nanowires stack up against silver and copper alone, they will not replace ITO and flat panel displays anytime soon. Wiley said, explaining that for films with similar transparency, copper-nickel nanowire films cannot yet conduct the same amount of electricity as ITO. Instead, we're currently focusing on applications where ITO can't go, like printed electronics, he said. The greater stability of cupron-nickel nanowires makes them a better alternative to both copper and silver for applications that require a stable level of electrical conductivity for more than a few years. Important for certain printed electronic applications, Wiley said. Interesting. Printed electronics combine conductive or electronically active inks with the printing process that makes magazines, consumer packaging, and clothing designs. Low cost and high speed of these printing processes makes them attractive for the production of solar cells, LEDs, plastic packaging, and clothing. A Durham, NC startup company, NanoForge Corp, which Wiley co-founded, has begun manufacturing copper-nickel nanowires to test in these and other potential applications. So it's from www.computescotland.com. Okay. So NanoForge Corp, so I looked that up because it was one of the keywords up here. Manufactures copper nanowires, which are long filaments of copper 10 times thinner than the wavelength of visible light. The company was incorporated in 2010. It's based in Cary, North Carolina. There's their address. It's nanoforge.com. And I found it from investingbusinessweek.com on their website. My thoughts. The keywords copper nanowires plus filaments. So those would be graphite. Then we have the wavelength of visible light have come up in previous well videos. Waiting to see if there's a formula after doing more research. Keyword copper wires will be in the next video. The reason I'm waiting is because there's so many videos about copper and nanowires. It's like there's like 50 of them. So I didn't want to do too many formulas because it gets too confusing. So I'm just looking to see what they come up with and then figure out what it's supposed to mean. Okay? Thanks for watching.